Hi guys, Miss Venable here, bringing you an acid-base activity today, and we're going to be dipping some indicators and squirting some indicators. So first we're going to take a look at the samples that we want to test the pH of, and all of these are going to be liquids, and let me show you a picture of what that looks like. So here we have our 5 samples, and what we want to do is determine the pH of these. Some of these paper indicators are just sort of vague. They just kind of tell you acid or base. Other paper strips are a little more accurate. So the samples we're going to test are water. This is distilled water. Lemon juice, and I have diluted it with some water. Household vinegar, also diluted. A baking soda solution, I just mixed baking soda in with our water. And last but not least is household ammonia, which is a really common cleaning product found in glass cleaners. Okay, so first I'm gonna show you guys paper indicators. Paper indicators are usually just little paper strips, and you never really want to touch these with your hands, because if your hands are wet at all, it'll change, and so you want to save them and make sure they stay dry until you're ready to dip them in the solution. So this is called red litmus paper, and it comes in a little vial like this. It's not actually red, it's pink. I don't know why they call it red. But red litmus paper, if you dip it in an acid, something acidic, it just looks wet. But if you dip this in something that's a base, it's going to turn blue. So if it stays red or just looks wet, didn't put no change, none. But if it turns to a blue color, then you're going to write the word blue, because that indicates that it changed. Okay, it's kind of a purple color, but it's actually called blue litmus paper. And it does the exact opposite. In a base, it just looks wet. It's the same color, it just looks wet. But if you put this in an acid, it will change to like a reddish pink color. So that comes in a little vial. Looks like this, blue litmus paper. And again, don't handle that with your fingers. The last one I think is much, much cooler. The last one is called universal indicator paper, and it's kind of my favorite because it has a color chart that comes with it. So not only can you get a range of colors out of this, you can also kind of tell the pH. So what you guys are going to do is say the color, and you're also going to give a value, a pH value that you'll read off of this chart. Okay, so we're going to proceed to dip all of these. Okay, I'll show you the first one. So for the distilled water, we're going to dip the red litmus paper. Okay, and it just looks wet. There's no color change there. And now we're going to dip the blue litmus paper. No change there, it just looks wet. And now we're going to dip the universal paper. Alrighty, and you have to read the color chart on this one. So I'll let you guys decide what you think for that color. It's not that green, it's closer to that yellow right there. Okay, then we just repeat that process for all of these. So I'm going to do all of them and lay them out, and then I'll get back to you. Alrighty, so we are back, and I've dipped all of these. Let's take a look at the lemon juice first. So my pink stayed pink. My blue litmus changed to red, because I can see that it's really more of a pink color there. My universal paper, it's more of an orange color than it was. Let me see if I can match that up. I'm not sure, 4 or 5. You guys can judge that for yourselves. Okay, for the vinegar, the pink stayed pink, the blue turned red, and And my universal is, I think, even more orange than the last one. So let's judge that. Kind of more, excuse me, not more orange, but like almost red. Kind of getting down there. Okay, for the baking soda, pink pretty much stays pink. Blue stayed blue. And then for pH, it looks, for the universal, it looks something like that. Match those colors. There you go. And then for the ammonia, ooh, this time red turned blue. Blue stayed blue. And for the universal, looks like I've got a shade of green here. It's a little, just to compare it, kind of two different shades of green for the baking soda and for the ammonia there, so you kind of have to judge that. And the important thing with these is that you read the color right away, because the color will change over time. All right, next we're going to look at some liquid indicators. So we're back with our 5 liquids samples that we want to test: water, lemon juice, vinegar, baking soda, and ammonia. And now we're going to test the pH of these with some liquid indicator solutions. The first one is phenolphthalein, and it's a clear liquid. We just use 1 drop of these. And phenolphthalein doesn't do much in acids, but in bases, it turns a bright fuchsia pink color. It's pretty neat stuff. So we will use that to test our samples. And then the other one is called universal indicator solution. And it has a whole range of colors. So we can kind of match the color to the pH. So we will be using this color chart for that to match our colors. Okay, so for starters, I just need to make 2 wells for each. I don't want to contaminate what's in my cup here, so I'm going to put water in one well to test with the phenolphthalein, and I'm going to put water in the other well to test with the universal indicator solution. So we'll just put some of our water in the well, almost fill up the top. Okay. And then here goes a drop of the indicator phenolphthalein and nothing. All right, a drop of the universal indicator solution. Ooh, that's a cool color. So I have to look at that color and then match it to the pH on the screen. It's sort of a greenish gold. Alrighty. So now we're going to do the lemon juice. So same deal. I got to put it in the well. Almost fill up the well with the sample that you want. You want a great amount of what you're trying to test. And then for your indicator, you just want to drop. Okay, so this is the lemon juice. No change there for the phenolphthalein. For the universal, I got a bright red. Okay, so we're going to compare that to the color chart. I'll let you guys judge the pH. And write down the numerical value when you're looking at this color chart, because it tells you, pH 3, 4, 5. So write down this numerical value for those. Okay, let's do the vinegar. So first well, second well, phenolphthalein, no change. Universal indicator. Ooh, even a darker red. If you can compare the lemon juice and the vinegar got even darker. So again, take a look at the color chart. I think you're going to be in this range somewhere. Okay, now let's try the baking soda. So there's my wells with my samples. And then the first one here is the phenolphthalein. Ooh, I'm getting a pink color. Okay, so there's that bright fuchsia pink color that I mentioned. Phenolphthalein only changes color for bases. All right, and now let's try the universal indicator. And I'm getting a dark dark yellow greenish color. Not like a Kelly green, but like a foresty sort of green color. So we'll compare that to the color chart. Closest color there. I might have to guesstimate a little bit. Maybe like 7.5. It's sort of a darker green, but it hasn't quite turned blue. Or maybe 6.5, maybe like a yellowish green. Alrighty, and then last comes my ammonia. So let me flip this around. Let me do a couple of wells here of ammonia. Alright, and the first well, I'm going to put my phenolphthalein. Ooh, dark fuchsia again. It's really bright pink. I love that color. I had my fingernails painted that color last week. And then here is the universal indicator solution. And for this one, we're getting, this one is darker than our last one. We're getting a much higher pH. So compare that color to your chart. So that should get you all the data you need to do the acid-base activity. Thank you so much for joining me.